together with an introduction to BFO 2, in which I will describe the changes which have been proposed for BFO 2. Alan will then take over and describe some more technical aspects of the OWL formalization of BFO 2. And then in the third section, we will have the opportunity for what I hope will be brutal and hefty critique. There will be a bit of opportunity for questions in the earlier parts, but the more questions you have, the less time there will be at the end for brutal and hefty critique. So that's up to you to make the balance. Let me just start. BFO is intended to be a simple top-level ontology, which is primarily intended to support scientific research, but which is also now being used for other purposes. So it has more than 100 projects which are using it, and some of them are quite large. Many people rely on it, which means that if we make changes, then they have to be very well reasoned through. And this presentation is part of that process of reasoning through the proposed changes. There are, at the moment anyway, no abstract entities represented within the BFO ontology, so we don't do numbers. If you want to do numbers, then you should buy the axioms of Peano arithmetic. We don't do propositions because propositions are not the kinds of things that you can do scientific experiments on, because they live in some sort of Platonic heaven, and we don't do heaven. But it may very well be that in order to represent interesting things like hypotheses or explanations, that at some stage we will need to do some work on something like propositions. But for the moment, we focus not on propositions in the abstract sense, but on information artifacts such as publications, abstracts, databases, and so forth, which are the sorts of things that you can do scientific experiments on. Now, BFO is broadly speaking in the same philosophical school as Dolce. It overlaps with Dolce, it's just smaller. It's deliberately smaller because we do not want to tread on the territory of any domain ontology. So BFO is completely formal. It deals with only those kinds of entities which can exist in any domain. And by domain, I mean things like physics, or the theory of light, or government administration, or Alzheimer's disease. Now, BFO is based on three fundamental dichotomies. The first is between two ways of existing in time. On the one hand, some entities exist in time by continuing to exist. These are called continuants. And some entities exist in time by occurring or happening, and these are called occurrence. So we divide entities. Entity is the completely general catch-all term. We divide entities into continuance and occurrence. There may be other kinds of entities, but the BFO is interested in continuance and occurrence. BFO does not make any assumption of exhaustiveness. If somebody finds that there are entities which are important for scientific investigation which are not dealt with in BFO, we want to hear about that, because BFO would like to be adequate to all scientific investigation. Secondly, we make a distinction between dependent and independent entities. Independent entities are all continuants for BFO. And they are things like people, chairs, laptops, planets, tennis balls, buildings, and so forth. They are things which exist independently and in their own right. They do not need anything else in order to exist. Dependent entities are what some people call attributes. Qualities that would be an example of dependent entities for BFO. Also, occurrence are dependent entities for BFO. Every occurrence depends upon some independent continuant. So there is no motion without a thing which moves. Dependent entities depend on their bearers, which are independent entities. And then thirdly, we have a distinction between what Buffo is pleased to call universals on the one hand and instances on the other hand. Universals are the sorts of things which scientists refer to when they use general terms like cell or electron or planet. So there is a universal cell which has many, in fact indefinitely many instances. Now Buffo represents instances in reality by representing universals. So there is a universal continuant and there is a universal occurrent. These are very high level, very general universals. There is a, I need some power. There is a universal dependent entity, actually specifically dependent entity, and there is a universal independent continuant entity. Again, very high levels, though at slightly lower levels than the levels that are occupied by continuant and current. And so that just summarizes what I just said. And that summarizes it yet again. This should say specifically dependent continuant for reasons which will become clear in a minute. So qualities are specifically dependent upon independent continuants. And processes are specifically dependent on independent continuants. And everything above this line is a universal, and everything below this line is an instance. So if some instance is an instance of the universal independent continuant, then it's also by inheritance, because these are subtype relations, an instance of the universal continuant. For instance, every instance of the universal temperature is specifically dependent upon some instance of the universal independent continuant, because only independent continuants have temperature qualities. Now, all of this is not rocket science. I hope that's clear. We are attempting to be quite simple, but at the same time to be quite expressive when it comes to addressing the needs of scientists in talking about the way in which the world is structured. And that Buffo is an ontology which is designed to serve as a starting point for the top-down part of your ontological building efforts. And every sensible ontological building effort should involve a bottom-up part which steers the domain ontology work, and a top-down part which ensures that the domain ontology work that you do will have at least a chance of being interoperable with the domain ontology work which everyone else is doing. So the way in which you use Buffo, and Alan will talk a little bit more about this later on, is if you're using Protégé to build your ontology, you import Buffo. You will be able to import Buffo in the version 2 version very soon. In fact, you can already import the release for review version. And then you work your way down the Buffo hierarchy, which is quite small, until you get to the Buffo term which is relevant to your particular domain. And if you're building a cell ontology, then it's going to be object. And then, in fact, everything else in the cell ontology is just a child of the Buffo term object. So for cell ontology, using Buffo is, in fact, almost completely painless. And ideally, you should hide this stuff so that you won't upset your users. So Buffo is not something which is designed to be shown to mortal beings. It's something that should work inside the engine. Now, I think it's pretty obvious what the benefits are. So if we all share the same upper level ontology, then we can all profit. If someone makes mistakes, they will learn something which they can then communicate to everyone else who's using Buffo. And then the lessons which people learn will cascade more quickly through the ontology building community. If we're all using BFO, then we can more easily reuse each other's work, which is very important in a big domain like biology. And we can also more easily criticize each other's work. I'm not sure why I put Pato there, but there are lots of things which might be more sensibly put there. And then it can lead to innovation. So people discover things which then can be passed back to all the other people. And we're seeing that that is happening now. That actually we are pushing forward the ontology development process because we have a common framework. So just a quick overview of the users of BFO. So all the Obo Foundry ontologies either use BFO or they were re-engineered to be BFO compatible, and usually that was quite trivial. NIF Standard uses BFO as its top-level ontology. The Eagle Eye, Vivo, CTSA, Connect Resource Registry Consortium uses BFO. The IDO Consortium, which is in a way a proper part of the Obo Foundry candidate list, uses BFO. So this is the Obo Foundry. These are the ontologies in the Obo Foundry which are either already full members or they are candidate members or close to being candidate members. And there are other ontologies which would like to be close to being candidate members, which are not listed here. The IDO Consortium I mentioned, and then there are others. So you can see a list here of the projects or the ontologies which are using BFO as their top level. That's probably by now quite well-known picture of the original organization of the Obo Foundry. It's now a bit bigger than that, but the organization is based on BFO. So here we have granularity, so small stuff is down here and larger things are up there, populations would be up here. And then here we have the relation to time and the distinction between independent and dependent entities. And the BFO 2 will have specifically dependent entities and then other kinds of dependent entities, which we will talk about in a minute. Reverse engineering the gene ontology so that it would be compatible with BFO was, on the face of it anyway, quite easy, because the gene ontology is divided into 3 parts, which correspond quite well to the 3 top-level terms of BFO 1.1. And there is a longer story to be told about this, but this, in any case, is the way things ideally would look as far as this particular association is concerned. Now, we have continuance. We have continuance, independent continuance, and specifically dependent continuance. I'll explain what the specifically means later on when I need it. There are 2 kinds of specifically dependent continuance, which we call non-realizable and realizable. It would be better just to use the word quality here. So qualities like temperature, mass, length, and so on are all non-realizable dependent continuance. BFO recognizes 3 subtypes of realizable dependent continuance, namely functions, roles, and dispositions. This is not intended to be exhaustive. Each of these things have instances. So there are instances of quality. Right. Now, if there's anything which is close to rocket science in this presentation, it's the thesis that there are instances of qualities. That is to say, I have a temperature now, and this is my temperature. It's an instance of the type temperature quality which inheres in me. You have a temperature, which is a quality which inheres in you, an instance of the type temperature quality. Now, it may be that your temperature is exactly the same, namely 36.1 degrees, as my temperature, but that just means that your temperature instantiates the same universal as my temperature. They are distinct. We cannot share temperatures, we cannot swap temperatures. Temperatures cannot migrate because specifically dependent continuants are dependent upon specific variables. And it's the same with functions. Your heart has the function to pump, and that's its function. It's an instance of the universal pumping function. My heart has the function to pump, and that's another function which I have, which is an instance of the same universe. Now this is, for some people, irritating. Those people should leave the room.
They should stand up and defend their position.
No, that's you missed the beginning. I said that hefty critique is reserved at the end. They can come back at the end if they want. And then they'll miss all the good arguments. Yeah, but you weren't here at the beginning, so you missed them. So, realization is a process. Realizable dependent continuums, such as dispositions, are realizable. And to be realizable means that there are realizations. So a disposition, such as the disposition of a glass to break, is realizable because this glass has the power or the potential or the possibility of breaking in the way in which, for instance, my temperature quality, for instance, does not have a disposition to break. Or my lip doesn't have a disposition to break, because you can't break a lip. So the process of realization, which realizes a given disposition when a glass breaks, for instance, is dependent upon the glass, just as the disposition is dependent upon the glass. So we have specific dependence, and this is a relation, and relations exist on at least two levels, or there are exactly two kinds of relations. I will explain what this means in more detail in a minute. First of all, we have relations on the instance level. So my heart is dependent, my heart's function is dependent upon my heart. What this means is that my heart's function is necessarily such that if my heart ceases to exist, then the heart's function will cease to exist. And now on the type level, which is the level where you would be formulating an ontology, like the gene ontology, for instance, it may be that you will have a type level relation, which is defined in terms of the instance level relation. To say that the type function of heart specifically depends upon the type heart is to say that every instance of function of heart specifically depends in the instance level sense on some instance of heart. This is called the all-sum rule. So relations on the type level are all-sum formulations of quantified expressions which use the instance level relation, corresponding instance level relation. All right, we've seen this already. These are some examples of specifically dependent continuance. The quality of whiteness of this cheese, your role or my role as lecturer, the disposition of this patient to contract diarrhea. This is a slightly more complicated picture. We have on the left a quality which is a particular instance of redness of a particular fly eye. This is an instance of the universal red. And then it specifically depends upon some instance of eye, because you saw it when you were collecting phenotype evidence. And this instance of eye is an instance of that universal eye. And the universal eye is a sub-universal or subtype, because we use the word universal and the word type as synonyms, of the universal anatomical structure, and the universal red is its subtype of the universal color, according to Boff. Now, this is the first thing which is new to BFO 2.0, although it's old to the tradition out of which BFO grew. This is the idea that there can be reciprocally dependent continuance, or mutually dependent continuance, or interdependent continuance. So if you look at the textbooks of color theory, the textbooks which contain pictures of the color triangle, then they will tell you that there are 3 interdependent dimensions of variation within the structure of every color. And this is true whether it's paint color, or light color, or wine color, or hair color. All of those domains of color, which are different in some respects, they're all characterized by this 3-dimensional structure. Now, this is to be seen as according to Buffo, or at least according to this proposal, because this is new, it's being proposed. It's old in the sense that there are many. We are to view this as a picture of the internal structure of an instance of color. It has 3 parts which are interdependent parts. You can't have a whole which is a color instance without 3 parts, which is a hue, a saturation, and a brightness. And you can't have a saturation all by itself. A saturation can only exist if there is a hue and a brightness. A brightness can only exist if there is a hue and a saturation, and so on. So this is a familiar part of the history of part. All right, we've seen that about 7 times now, actually. So we have realizable dependent continuance. Roles, so the nurse role is realized in the activities of being a nurse, of becoming a nurse, signing the documents. Dispositions like fragility and virulence, and functions like pumping and unlocking. And so this is another picture of the same story. These things are specifically dependent continuants.